Yo, welcome back to the series called What the Hell is Organic Chemistry? This is my series where I'll help people who are struggling with organic chemistry. My name is Zeanium, and today we're gonna dive into what the hell is functional groups. Okay, so let's imagine a molecule, and your professor says something of the lines of, just identify the functional group. Just? I can't even identify myself before coffee, but today we're gonna fix that. We are gonna make you professional identifying functional groups. So what the hell is functional groups? So in simple terms, a functional group is a small group of atoms inside a molecule that determines how the molecule reacts. It's the personality of the molecule basically. And they appear over and over and over again in chemistry, so it's like memorable characters. I mean, you can think of it like game characters. So if you ever played any fighting games like Mortal Kombat or Street Fighter, then think of the functional groups as character in a fighting game. Alright, let's start with alkanes. So alkanes are just carbon and just hydrogen. Single bonds only. They are saturated, which means that all carbons have the maximum number of hydrogens possible. And they are non-polar, so they don't mix with water. And alkanes are very unreactive, so they do not like reacting with shit. So you can call them chemically introverted. And you can remember it by single bonds. So just like these is an alkane, all these. Alright, sweet. So an alkene is a hydrocarbon that contains at least one carbon-carbon double bond. An alkene is electron rich. And why is that? Because the double bond has high electron density, and the electrons are sitting above and below the bond, which are easily accessible. So whenever you see a double bond in the compound, that's an alkene. So whenever you see a double bond like this, that's an alkene, basically. Alright, so the next one is alkyne. It's a hydrocarbon that contains at least one carbon-carbon triple bond, and even more electron density than alkenes because it has 2 pi bonds and high reactivity. Now, this is where alkyne gets spicy. If the triple bond is at the end of a chain, for example this one right here, and that hydrogen at the end, it's slightly acidic. Why? Because the carbon is sp hybridized. I made a video of geometry. If you haven't watched that, I'll suggest you're gonna watch that before you're gonna watch this. But yeah. Anyway, so it holds electrons closer to the nucleus and stabilizes the negative charge better, so the hydrogen can be removed. And so whenever you see a triple bond in a compound, that's an alkene, so like this. Then we have the benzene. So benzene is a ring-shaped molecule. It's aromatic, which means it's stable. And you will see this stupid ass molecule all over organic chemistry. So you can remember it by its ring. Well, it's a ring shape, so it's not that hard. Alright, then we have an alcohol. So an alcohol contains a hydroxyl group, which is OH, that is attached to a carbon chain. Why do I call it the drunken brawler? Because alcohols are touchy, they love interacting and constantly grabbing onto other molecules. Basically, just like a drunk, clumsy person on a Friday night. And how can they do that? By making hydrogen bonds, of course. So the oxygen in OH is highly electronegative and pulls electrons toward itself, which creates partial charges. So alcohol molecules stick to each other and stick to water, which is also a polar functional group, which means that they can mix with water. And because of the hydrogen bonding, alcohols have higher boiling points than alkanes of similar size. For example, let's take ethane. It has a low boiling point, and ethanol has a much higher boiling point. Why? Because hydrogen bonding is a strong intermolecular attraction, and the more attraction you have, the more energy needed to separate the molecule, and the more energy, the higher boiling point. And how can you remember this functional group easily? Well, I usually think like, oh shit, I'm drunk, like, oh, just like this. So the next one is ether, the I. So what's an ether? An ether contains an oxygen atom that is bonded to 2 carbons, and they are relatively unreactive. But ethers are excellent solvent because they're slightly polar thanks to oxygen and can dissolve organic compounds. So they're like, I'm just here to help reactions happen, bro. And fun fact, diethyl ether was used as anesthesia in the 1800s. So how can you remember it easily? Well, it looks like an eye, like staring at your soul, like this. Right here. So yeah, alright, next we have alkyl halide. So what is an alkyl halide? An alkyl halide is a carbon chain with a halogen attached. And why do I call it the mercenary? Well, because alkyl halides are reactive, so they're ready to deploy like soldiers and designed for substitution reaction. Also, carbon halogen bond are polar, because the halogen pulls electron density and carbon becomes slightly positive. So nucleophiles will say target locked on. Feel me? So they're built for one mission, leave. And what I mean by leave is that halogens are great leaving groups, especially iodine is the best leaving group than fluorine. And the bigger the halogens, they leave more easily. And why is that, you may ask? Because they stabilize the negative charge better. So in reactions like SN1 or SN2, the halogen just leaves. I'll make a video about SN1, SN2, and E1 and E2 later. Don't worry, I got you, bro. So how can you remember it? Well, if you see that fluorine or bromine or chlorine or iodine is attached to a carbon, that's basically an alkyl halide. So yeah, just like these one, right? All right, then we have thiol, the swamp witch. Okay, so what is a thiol? A thiol contains a sulfur atom that is bonded to hydrogen and are attached to a carbon chain. Literally an alcohol, like an OH group, but sulfur replaced oxygen this time. So thiols are famous for one thing. They smell so bad, like rotten eggs or skunk spray. Thiols are more acidic than alcohols. Why? Because sulfur is larger than oxygen. So when it loses a proton, the negative charge is better stabilized. So a bigger atom spreads charge better and more stable conjugate base, the more acidity. Alright? And thiols can react with each other to form disulfide bonds, just like this one right here. It's where two thiols combine and they create a covalent sulfur-sulfur bond, which is very huge in biology because proteins use disulfide bonds to stabilize the structure and lock the shape in place. And without it, well, proteins lose their structure. Okay, so how can we remember it easily? Whenever sulfur is here in the game, it's called di. So it's an alcohol, but sulfur replaces oxygen. That's basically it, just like this. Alright, aldehyde, the edgelord. So what is an aldehyde? An aldehyde contains a carbonyl group, a C-double-O bond, with at least one hydrogen attached to that carbon, which is positioned at the end of the carbon chain. That's the key. It's always on the edge, just like its name, edgelord. And aldehydes react quickly and are more reactive. Why is that, you may ask? Because it has less steric hindrance and only one carbon group attached, which makes it easier for nucleophiles to attack. They're pretty much exposed, like no protection, so you can remember it by it's always on the edge with a H, just like these molecules. So it's always on the edge. Alright, then we have the ketone, the king. So what is a ketone? A ketone contains a carbonyl group just like aldehyde, but it's positioned in the center of the carbon chain and bonded with two carbon groups, and no hydrogen attached directly to the carbonyl carbon. That's the difference from aldehyde. And why do I call it the king? Because ketones are more stable than aldehydes, they are less reactive, and in the center of a compound. So how can you remember a ketone? Well, I usually say ketone, one king, and the king sits in the center. So if the carbonyl is in the middle of the chain, that's a ketone. So if it's on the edge, it's an aldehyde. Simple. So just like this, that's a ketone. Alright, carboxylic acid, the poison queen. Well, a king needs a queen, right? So what is a carboxylic acid? A carboxylic acid contains a carboxyl group, a COOH group, that is usually at the end of a chain. So just like an aldehyde, the edgelord. And it can donate a proton, and carboxylic acids release the proton into the solution, lower the pH, and react with bases immediately. Okay, so how can we remember it? Well, look for a carbonyl group, C-double-O bond plus an OH together. So if you see both attached to the same carbon and on the edge, that's a carboxylic acid. So just like this. Alright, then we have the ester, the footballer. So what is an ester? An ester contains a carbonyl group that is next to an oxygen bonded to another carbon. And esters smells good. They're pretty famous for fruity smells like sweet aromas that use in perfumes or flavoring. Like for example, banana smell, pineapple smell, apple smell, whatever smell. So why do I call an ester the footballer? Well, listen here. In my eyes, it looks like a footballer. Let me show you. So we have the head. Let me draw a ponytail like this. But that was an ugly ass ponytail. It has a ponytail like this, and then football is right here. So it has a body right here. It has a body. It has a stomach, and then its leg is kicking the ball. And then the other leg is here, but kind of looks like she's kicking the ball. And how can I remember? Well, so how can you remember it easily? Well, her name is Esther, she's a football girl, and she smells good. So it looks like this in a molecule. Those are esters. Alright, amine, the sweet brawler. So what is an amine? Well, an amine contains a nitrogen atom, an N, with a lone pair of electrons and are attached to one or more carbon chains. So why do I call it the street brawler? Well, I think of amine as Ryu from Street Fighter games. So since his special attack is blue like amine, and amines are basic and electron rich, so they're ready to accept protons and donate like acid. And many amines smells like fish, rotting seafood, and nitrogen compounds usually have fishy smells. So how do we remember it? Well, if you see a single N in a compound, that's an amine. So just like this one. This is an amine. Alright, then we have the amide, the grandmaster. So what is an amide? An amide contains a carbonyl group bonded to an amine. And why do I call it the grandmaster? Because amides are extremely stable and peptide bonds are amides. So proteins built from amino acids, and the amino acids connect through amide bonds. So without amides, no proteins basically. So how can we remember it? Well, look after a carbonyl group, a COO bond that have a neighboring amide. So an N, just like this. Nitrile, the sniper. So what is a nitrile? A nitrile contains a carbon-nitrogen double bond that is written as C-triple-N, and it's located at the end of a carbon chain. So why do I call it the sniper? Because nitriles are linear and precise in reactions, just like snipers. And cyanide, fun fact, has the same structure as nitrile. So how can you remember it? Well, look after a triple bond on a nitrogen, or like CN like this, like Cartoon Network or something, but yeah, just like that. Alright, epoxide, the ring goblin. So what is an epoxide? Epoxide is a cyclic ether with a 3-membered ring containing 1 oxygen. So basically an ether that made bad life choices. Why do I call it the ring goblin? Because epoxides are tiny, extremely strained, and highly reactive. So they snap open very easily. So a 3-membered ring has a bond angle of 60 degrees, but carbon want 109.5 degrees, so sp3 hybridized. And that angle of strain, pain, constant pain. And because of the ring strain, epoxides open easily, and they undergo a ring opening reaction and react with nucleophile. So you don't need much force, they're already uncomfortable. Just poke them and they collapse, basically. Alright, so how can we remember it? Well, look after a tiny oxygen in a triangle. So think pizza slice, or AJ from Beta Squad, or something else that's triangle. So it'll be like this right here. This is the epoxide. Alright, then we have imine, the DJ. So what is an imine? So an amine that has a double bond base. And yeah, it's a carbonyl remix. So instead of oxygen, it's the N this time, or the amide this time. So yeah, just like this. Right? Alright, acid chloride, the berserker. So what is an acid chloride? An acid chloride contains a carbonyl group directly attached to chlorine. And why do I call it the berserker? Because acid chlorides are extremely reactive and violent throughout water. So they have no chill, absolutely no chill. So how can we remember it? Well, look after a carboxylic acid, but the OH is Cl basically. So just like this. That's acid chloride. Anhydride, the twins. So what is an anhydride? An anhydride contains 2 carbonyl groups that is linked by 1 oxygen. So it's derived by 2 carboxylic acids, and the name meaning anhydride without water, because it forms when 2 carboxylic acids lose water. So they are linked, shared power. And how can we remember it? Well, it looks like 2 esters playing football together. So like just with 1 ester, it's 2 esters this time. Hopefully you can see what I mean, so I don't have to draw it. So yeah, this is anhydride right here. Alright, nitro, the explosive diva. So what is a nitro group? A nitro group contains a nitrogen bonded to 2 oxygen, where 1 positive charge on N and 1 negative charge on O. Alright, so resonance spreads the negative charge between those 2 oxygen. And why is it called the explosive diva? Because nitro groups strongly withdraw electrons and create massive polarity, which makes molecules highly reactive. So they pull electron density like it's about me, bruh. And they have boom boom energy. And what I mean by boom boom is that nitro groups are found in TNT or other explosive shit. So that's how you can remember it basically. But you can also remember it by it has 2 formal charges, like I said, nitrogen positive and one oxygen is negative, or it can look like NO2, just like this right here. So like, no, too late, it's gonna blow. Like, that's how you can remember it easily. All right, fire ether, the shadow root. So what is a fire ether? A fire ether contains a sulfur atom bonded to 2 carbon groups, which no hydrogen attached to the sulfur. So it's basically an ether remix. So the oxygen is now as, well, sulfur. And yeah, so how can you remember it? It's basically an ether, but sulfur is replaced with oxygen, just like the thiol. And again with the di, so I know sulfur is in the game. Alright, then we have azide, the silent killer. So what is an azide? An azide contains 3 nitrogen atoms that is connected in a linear arrangement, often written as N3. And fun fact, azide can release N2 gas explosively. And why is that important? Because nitrogen gas N2 is extremely stable. So when azide decomposes, it forms N2. So a huge stability gain and huge energy release. And therefore, thermodynamics says, boom. And how can we remember it? Well, look at the 3 nitrogen atoms in the line. That's it. So if you see N or N3 attached to a carbon, that's an azide. So basically just like this. Alright, so now that we mastered the art of identifying functional groups, let's look at the compound again that we're given by the professor at the start of this video. Alright, so let's test it. Alright, so this right here is a carboxylic acid, this right here is an ester, and this right here is a benzene. Boom, that's basically it. So yeah, let's do some more practice exercise. So identify the functional groups in the compound below. Alright, so let's start with this one. This right here is an ester, this right here is an amine, to be more specific it's a secondary amine, and this right here is a benzene. Boom, first one done. This one is an ether, it looks like an I, like I told you. This also looks like an I, then it's an ether, a benzene, 2 benzenes, an alkyl halide, 1, 2, 3, 4 alcohols, and another ether. Boom, that's about it. And then we have this one. There's a benzene here, there's an ester here, there's also 1 ester here, 2 esters, and a tertiary amine. Boom, that's about it. Let's do one more. Alright. N is bonded with a C that is bonded with the carbonyl group. There's an amide, this functional group, an amide. This is a benzene. This is a tertiary amine. And this is a benzene. This one is actually a pyridine ring, but that's more advanced, but we'll get there, don't worry. And this group, an alcohol, this whole thing right here is a phenol, an alcohol again, an ether, a ketone, since it's in the middle, right? And amine, that is tertiary, and alkene. So yeah, that's basically it about functional groups. So if this video helped you, make sure to leave a like. Any support is appreciated, honestly. And comment down below what else you want me to cover. Like something that is bothering you in class, I'll make a video just for you. Or just say hi. And join the Discord down below for homework help and a great community. And what the hell are you doing? Join me when I'm live and smash subscribe. Until then, eat well and stay hydrated.